Okay, good day everyone. Now we are going to present about high voltage assignment. We did the comparison between rapeseed oil and mineral oil. So our group member is Mama Shamil, Roman, and Sharil, and Tinagaran, me. So let's proceed. Okay, so introduction, we talk about the breakdown voltage. The breakdown voltage is the minimum voltage that causes a portion of an insulator to become electrically conductive. This can be due to tracking or treeing if it becomes, or due to a carbonizing effect of the from the electricity, so it can create a conducting part. So in solid insulating material, it usually creates a weakened part within the material, creating permanent molecular damage. Electrical breakdown may be a momentary event or may lead to a continuous arc if the protective devices fail to interrupt the current in the power circuit. So we did a lot of literature review on the material. So from that literature review, we concluded that they preferred rapeseed oil more than mineral oil because there are a lot of advantages compared to the mineral oil. Rapeseed oil has a lot of advantages. One of the advantages, it is fully biodegradable, which means it is environmental friendly. So another one is flash point exceeds 300. Flash point is like it represents a chemical activity of the oil, which means if it's high, it will more or less likely to combust. So it is good that it's high. 300 is considered a high value for a flash point, and it possesses good electrical properties, and the inception and propagation of streamers in insulating rapeseed oil are close to those observed in mineral oil. So proceed. I'll give it to okay. The experiment that they did to check for PD, they used this device. This device they call it oil vessel. Here we can see the high voltage electrode. It is in the form of a needle, and the electrode, they said it satisfies the requirement in IEC 1072. The curvature radius of its tip is 3 micrometer. The grounding electrode is a ball electrode with a diameter of 13 millimeter. The distance between the needle and the ball electrode is 50 millimeter. 3 observation windows, 1, 2, and 3, were made of quartz glass for PD observation. The PD observation, they do it by corona camcorder or digital corona camcorder, a pulse current detector, a Leroy card digital oscilloscope. With 10 successive measurement of PD inception voltage, they took the mean value and standard deviation, and they calculated it to obtain the result that the rapeseed oil has a much better properties than mineral oil.
Assalamualaikum and good evening. My name is Muhammad Shamil. So next, I would like to share about the result of comparison. First, in terms of dielectric properties. So in this experiment, we use a 25 mineral oil. Normally at online, if you want to buy a oil, there are 4 types, which is 10, 20, 25, and 45. So all of these type of mineral oil are provided in online if you want to buy. Normally the number is based on the temperature. For example, in this mineral oil, it operates at 25 Celsius. So we compare a rapeseed oil and 25 mineral oil. So from this, we can see all of the result of the experiment. For example, for the acid value in a insulating rapeseed oil is 0.03, and for mineral oil is less than 0.03. So, and also the breakdown voltage is insulating rapeseed oil is higher than mineral oil. which is 73.6 kilovolt, and for mineral oil is higher than 35.0. And also for the dissipation factor for insulating rapeseed oil is 0.75, and for mineral oil is less than 1, but normally higher than 0.75. And also for the permittivity of the insulating rapeseed oil is 2.93. So this is the result of the breakdown voltage. So in this experiment, they measure the electrical AC strength and carry out under IEC 156. So they provide a supply for AC voltage with the frequency 50 Hz AC voltage, and it start to rise from 0 to 3 kilovolt, increase right up to the breakdown. So from this experiment in a room temperature, the breakdown is for rapeseed oil is 73.0 kilovolt. So what else? So from the experiment, they say that the breakdown of the rapeseed oil is higher than 25 type of mineral oil at same absolute water content in oil. So with the increase of relative water content, breakdown voltage of both type of oil decrease significantly. So as we can see from the graph, with the increase of relative water content, the breakdown voltage of both type of oil decrease significantly. So actually, the cause breakdown voltage to reduce because of the contamination of the insulation and the presence of moisture inside the insulation. So next is a dissipation factor. So dissipation factor is the energy loss. Normally inside the insulation it have a capacitance, and this capacitance will cause a capacitance loss. Normally the energy is lost in terms of heat. So dissipation factor is measure how much the energy lost in terms of heat. So experiment for measuring dissipation factor of rapeseed oil and mineral oil were carried out under standard of IEC 247 and GB/T 507 etc. So the result of the measurement are shown in the graph. So after the rapeseed oil was refined, it is done decrease significantly. So we want a very good insulation might have a low dissipation factor. So from this experiment, as we can see, the refined rapeseed oil is lower than natural oil, and rapeseed oil that not refined. So at the same temperature, time data of insulating rapeseed oil is higher than mineral oil.
Okay, my name is Sharil, so I'm going to discuss about the result of comparison relative permittivity. It's more focused on the permittivity of the insulation. So the relative permittivity rapeseed oil almost does not change after refined. With temperature increasing, relative permittivity rapeseed oil decrease slightly as well as mineral oil. So this is mean that the permittivity of mineral oil and the permittivity of rapeseed oil is very different. Rapeseed oil, when the temperature is increased, there will be no effect on the breakdown voltage. But mineral oil, when there is temperature increase on the insulation, the breakdown voltage will be decreased because of the temperature. So generally, relative permittivity rapeseed oil is higher than mineral oil. The result comparison. So the next is the result of comparison partial discharge inception voltage. All PD measurements were carried out at ambient temperature according to the standard IEC 1072. 10 partial discharge inception voltage of mineral oil and insulating rapeseed oil were measured. So we measured two types of mineral oil and rapeseed oil for the partial discharge inception voltage. So the mean value are recorded here. So PD inception voltage, the electric liquid primarily influenced by electric moisture content. So the lower relative moisture content of type dielectric liquid can result in higher PD inception voltage than electric. So when there is moisture inside the insulation, there will be some effect on the insulation, either either rapeseed oil or mineral oil. But here, when we see on the table the value of the breakdown voltage on the insulation rapeseed oil and mineral oil, they are different. They are very different because of the type of insulation. So when there is a moisture, insulation rapeseed oil breakdown voltage is very high. Say 73.6 breakdown voltage for rapeseed oil is very high, while the 30 type mineral oil is very low, around 35 kilovolt. So this is mean that rapeseed oil is better than mineral oil. This one is, we talk about the partial discharge ultraviolet image of PD under AC voltage. So inside here, experiment has been done, and they're using some of corona camcorder to record, to take the picture about the partial discharge between the mineral oil and the rapeseed oil. So because this partial discharge actually effect like a starting effect to its insulation to make a breakdown voltage. Like when there is a lot of partial discharge, it's easy for the insulation to make a breach so it can cause breakdown voltage. So when you see at the insulation mineral oil, there is a lot of partial discharge. This is they have test around 30 kV AC voltage. 30 kV AC voltage is very high to test the insulation. So the actually partial discharge is photon number per minute. The capture is like a very fast capture. Photon number per minute for insulation mineral oil is 58, while for insulating rapeseed oil 52. So it's very big on the mineral oil. So when we see here, this is the camera show that partial discharge for each second. They count for each second. So when you see, this is a lot of partial discharge and at the insulation mineral oil, while the insulation rapeseed oil is very low amount of partial discharge. So it take time. In rapeseed oil, it take time to break down, but in the mineral oil, it take short time to break down. So that's all from me. Thank you. I will pass to the Lukman.
3.
Okay, Assalamualaikum. Let me continue this presentation. So just now Syaril present about the first test on the comparison between the rapeseed oil and the mineral oil in terms of the UV image of partial discharge under the AC voltage. So just now Syaril take a bit about the testing on 30 kV. So I would like to continue on 35 kV. So for 35 kV voltage testing on the both dielectric. So for the insulating mineral oils, it reached 100 photon number of proton per minute, while the photon number per minute in insulating rapeseed oil reached 113, which is greater than the insulating mineral oil. So we can see here the rapeseed oil is greater than the mineral oil. So let's proceed to the 40 and 45 kV testing to the both insulating materials. So for the 40 kV AC voltage testing, the photon numbers per minute for mineral oil is 141, while the rapeseed oil 161, as shown in the figure. So we can see the rapeseed oil is greater number of photon numbers per minute than the mineral oil. Same to the 45 kV AC voltage, the photon numbers per minute for the rapeseed oil is greater than the mineral oil, which is 278, while the mineral oil is 233. So from the testing of the applied voltage towards the both dielectric, which is insulating mineral oil and the rapeseed oil, we can conclude that at the 30 kV, at first the insulating rapeseed oil is a bit lower than the mineral oil, the photon number, and after that, when you increase the voltage testing, 35, 40 and 45, so the insulating rapeseed oil is greater than mineral oil until the 45, you can see here. So I think that's all from me.
Okay, now we're going to see about the overall summary about the results that we have obtained. So in the table 2, it shows that the PD inception voltage of the insulating material oil are lower than the insulating material rapeseed oil. This indicates that the PD occurs more easily in insulating mineral oil than the rapeseed oil. So another one is that breakdown voltage of rapeseed oil is higher than mineral oil. This is due to the when the test voltage is 30 kV, the test voltage exceeds the PD inception voltage of mineral oil by 20% compared to the rapeseed oil, which is lesser, about 6%. So it has low PD inception voltage compared to the rapeseed oil. Rapeseed oil has lower voltage inception value compared to the mineral oil. The PD pulse play a more important role than the PD pulse count for the photon generation in insulating oil. So in conclusion, the breakdown voltage of rapeseed oil insulating oil is higher than the insulating mineral oil. At the same temperature, the dissipation factor of insulating rapeseed oil is greater than that of the insulating mineral oil. Because the relative moisture content of insulating mineral oils are greater than insulating rapeseed oil, partial discharge insertion voltages of mineral oil are 3.5 kV lower than in rapeseed oil. The digital corona camcorder can be used to observe photon numbers, like we showed you earlier, the test rig, the oil test rig, and then for the photon analyzer for the 30 kilowatt up to 45 kilowatt. It can be used, digital corona camcorder can be used to look at the photon numbers and everything. So when the test voltage exceeds inception voltage of partial discharge significantly, the photon numbers observed in insulating rapeseed oil are greater than in insulating mineral oil. And that's all. Thank you.